which is read by Mr. Sueka. I'm currently served as a data scientist and also functional staff at BPS in Statistical Information Directorate. And I have been involved in the big data project with Mr. Setia since last year. So I think it's been 1 year. So I'm pretty new in this big data world and also machine learning world, so let's learn together. Well, actually, I don't consider myself as a trainer, but rather I'm a person who learned a little bit about machine learning, and I would like to share this with you. So please do consider this opportunity as a chance to learn together. And also feel free to interrupt me if there's something that you don't understand or if I speak too fast. Okay, so let's just jump into the slide. Okay, first of all, I want to do some quick self-check. I believe that yesterday you already got the material about introduction to machine learning. I would like to ask if any of you has an experience with machine learning before. You can raise your hands using the raise hand feature on the Zoom. No one raised hands? Okay, is anybody there? Actually?
Okay,
okay, no?
Participant, but I think your response will be valuable to so we can adjust the speed align with your experience. Could you give response either from raise hand button or type in the chat box?
Or you can also just turn on your mic. I believe just say that if you already have experience with machine learning or not. But since no one answered, so I just
very good.
Thank you,
I think Ms. Nur Adila from Malaysia.
Oh, thank you very much.
Start exploring machine learning starting this year.
Yeah, I'm also a beginner, so let's learn together, Ms. Nur Adila. We'll look forward to learn together with you. And also, has anybody has an experience with Python before? Or maybe just try to type something with Python, just do some simple scripting like reading a file or importing CSV files. Anybody has an experience with Python before? Python is good, nice to know that. For those who use Python before, what libraries that you ever use? Did you ever use sklearn or pandas or numpy, for example? Jupyter, yes, that's the notebook. Okay, so you answered for the question number 3, nice. Okay, so only Farron answered. How about other people here? Before this, we have a project on sentiment analysis using machine learning. However, we are just user and subscribe to media intelligence from private company. Okay. Thank you very much for sharing your insight, Ms. Noradila. Terima kasih. Okay,
yeah, Jupyter is very good, right?
Yeah.
Yeah, it's related to our train today.
Yes. So for the hands-on today, we'll be using a Google Colab. So if you are familiar with Jupyter, so I believe that there will be no problem for you to try the script. You just need to shift and enter, and then you got the result of the script. Okay, so I think that's enough for the self-check. Let's just go to the next slide here. You're familiar using pandas and numpy, but only for self-exercise. Yeah, me too. But sometimes I also use pandas and numpy for finishing the job that my boss gave me. So most of the time I learn because I have to do it. So I think we all been there. Thank you very much for sharing your insight, Apriana. Okay, let's go to the next slide. Warming up. So let's refresh our memory about machine learning, shall we? Oh, by the way, have you downloaded the material that I upload through the Google Drive? Has anyone got the material yet? I mean, at least you just download the material and open the PDF file and also prepare the Google Collapse, the IPy file. Has anyone download the material? Or maybe we can provide the URL here. Let me see if I can share the URL. Okay, just need to close this. Okay, so this is the material for day 2. You can just go to this link. The link. Let me try to do this. Okay. And my material is in here in this folder, KN decision trees. So I think it will be better if you download the PDF and open it while I'm trying to explain it to you, because that way you will get more information about material. Okay, let's go back to this. So yesterday you already got a gist of what a machine learning is. Can anyone share their thought about what machine learning? Maybe just say it in your own word. Because if you go to the Google and then type what is machine learning, you can find so many definitions about that. But basically, machine learning is just what? Maybe you just can share your thought about yesterday's material. Can anybody share your thought? Or should I choose randomly from the list of the participants? How about Miss Desiree? Are you there? Do we have Miss Desiree? Did I pronounce your name correctly? Nope, she's not there, I think. How about Huimin? I mean, it's okay. We just learn together here. There's no right or wrong answer. I just want we all refreshing our memory together about what machine learning is. Or anyone wants to be a volunteer? Maybe Miss Noradila?
I think Miss Noradila, yeah.
Okay, yeah.
She answered.
Feel free to turn on your mic.
Halo.
Morning. Good morning. Selamat pagi.
Selamat pagi.
Pagi.
Okay, for me, secara how do I say? Can I say as like what I write in the chat? For me, the machine learning is automated modeling system, less human intervention, so that we can just give a little input to the machine, and they can give us insight that is beyond our limit.
Thank you very much for your answer. That's really correct. That's a very best answer. Thank you very much. But in my own word, machine learning is actually just this simple. It's giving the computers the ability to learn to make decisions from the data without being explicitly programmed. So what does it mean? It means that when you make a program or code, you need to define the exact steps, what the program is to do, like if, else, and things like that. But with machine learning, you just need to train the model, and the next time you have a new data, you just use that model. So there will be the computer can make decisions automatically. So that's correct. Thank you, Ms. Naradila, for your answer. It's really good to have participants really active and engaged in the talk. Thank you very much. Okay, the next question is, what types of machine learning algorithm have you ever heard? Can anybody share the thought? I think it's also explained yesterday in the yesterday's talk. Let's just, I do encourage all the participants to try to answer and talk, because we just learn together here. So no worries if you feel like you don't really understand about it. Do anyone wants to answer? Maybe Nguyen from Vietnam. Nguyen, are you there? Don't be shy. You can just answer it. Or Miss Rachel from Philippines. Or anyone wants to volunteer? Come on, guys.
Is it supervised and unsupervised?
Yes, it's a supervised and unsupervised. And there are also two other algorithms. I believe that Mr. Satya mentioned it yesterday. It's semi-supervised and also reinforcement learning. But in this lesson today, we just only focus on supervised. And tomorrow, I believe that there will be another talk about unsupervised machine learning. So what's the basic difference between supervised and unsupervised? You can imagine like you are teaching a kid. So supervised is like teaching a toddler. Maybe anyone has a kid here, 4 years old or 5 years old. When you want to teach them something, you clearly show them the thing and then mention the name of it. Like this is an orange, this is a banana, this is a watermelon, for example. And then you try to make the kid remember everything. And then after that, you will give them a fruit. Let's say it's a banana, and you will expect the kid to be able to answer correctly. Like, yeah, this is a banana. That's supervised machine learning. So you can see that from this illustration here, there's a teacher teaching the kid about 1 + 1 is 10. Well, this is clearly a wrong example actually, but we don't really focus on that. We just focus on how the supervised machine learning works. On the other hand, unsupervised machine learning is maybe similar to teaching a teenager or an adult maybe. So instead of sitting next to them and then teach them about 1 + 1 = 10, you just give them the problem and then sit them in a certain room and then ask them to figure out how 1 + 1 can be equal to 10. So that's the basic difference between supervised and unsupervised. In supervised machine learning, there's a supervisor here, the teacher, and in unsupervised machine learning, there's no supervisor. Okay, so this is another illustration of supervised versus unsupervised machine learning. So here an example that we teach the model, this is a duck, this is not duck, this is not duck, and then we give a certain animal and we expect the model can answer, yeah, this is a duck. And this is unsupervised learning. You give the model several animals and require them to be able to group the animal into certain category. So that's the unsupervised machine learning. Okay, so for the implementation in Python, we are so lucky because there's a library named sklearn or scikit-learn. For those of you who already download the slides, you can just click the link over here that I provide and it will bring you to the website of sklearn. It's still loading. Just wait for it. Okay. Can I bridge? Wait and see. sklearn provides all the function, all the API that you will be needed to do modeling with machine learning. Besides that, in Python, we will also be using the pandas. Pandas is also a library. We will use it mostly for data exploration and preprocessing. And for your information, these libraries are open source, meaning that you can just, you can find the code behind that library. And if you want to participate in improving the code, you can just go to the GitHub and then contribute. Maybe you find some error when running a code, and then you say that, okay, this is wrong with the algorithm, so I will just make a contribution and improve the code. Wait a minute, let me try to see the sklearn here.
Sorry, Miss Erica.
Yes.
I can access the link as scikit-learn.
Okay, thank you very much. I think there's something wrong with my internet. I don't know why it cannot open the sklearn website. So here it is. Sorry about that. I think there's some issues with the internet, but we can keep moving on. Okay. Okay, so you already know about the sklearn, pandas. If you feel like this is so intimidating, you feel like you never heard about sklearn or pandas before, don't worry, because we will have a hands-on when you can get a chance to get your hands dirty on the script. Okay. Okay, now we jump to the supervised machine learning. Here's the main topic today. Yeah, another illustration. So supervised machine learning is basically similar to teaching a kid. So they will learn patterns from existing data and applies it to new data. It requires a series of training to gain knowledge, because you know when you want a kid to be able to let's say to take a shower by himself, you will need to train them maybe several times until they can finally be able to do to take a shower by himself. So it's similar to supervised machine learning. You will train the model, maybe not once, maybe twice, thrice or more. It depends on the complexity of the data and the output that you want to have. But don't worry, because we have the library. So that's a good thing of having Python and also the libraries today, because we do not have to worry about the complexity behind all the computation. We just need to type a script and then run it. Okay, so this is the three main component of supervised machine learning. Okay, training, validation, and prediction. So as you already suggest that to teach something, we have to train it. That's why we have the training steps here. The training steps involve training data and test data. And then this is the learning algorithm. This is where the machine learn the task, and then it will produce a model as an output. And after that, we will do a validation. Validation will use the test data. Can anybody guess what this validation means? I mean, after we train, we need to validate it. So can anybody guess what validation means? Maybe someone want to share a thought? It's really intuitive, you know, just by translating the word. Anybody wants to answer? Let me see the list of the participants. Peron, are you there?
Oh, yes.
Hi.
Validation.
Yes, validation.
Okay.
Oh, by the way, do you have an experience with machine learning before? Sorry if I already asked this question.
No, I'm just trying. I'm not sure if it is machine learning or not, but I'm trying right now. I'm using they call it the model called, let me recall. It's now casting model. Now casting. Adila, Tengku, can you help me on this? What is the model called?
Pardon?
Now casting. Can you recall?
The model that you use or what?
Yeah, model. Can you recall the model? No.
Well, if you do not remember,
Never
that's
mind.
fine. That's fine. Let's just go to the question. What do you think about the validation? What validation is, in your opinion?
Validation, we need to check whether the decision is correct or not in real life.
Yes. So it's meaning that we want to measure the accuracy of our trained. So let's go back to the example of teaching a kid that I mentioned earlier. After like 1 week of a very long and exhausting training a kid, you're finally able to make them understand how to take a shower by themselves. And then you want to test it. How do you test it? Maybe you you take them to a new place, maybe when you go to your parents' house, and then you ask them to take a shower by yourself. Show your nanny that show your grandmother that you can that you are independent and can take a shower by yourself. And then they do it, and then you see whether whether they do it correctly as you train it at the home. So basically, test the data validation is using different set of data, and you won't just compare whether your trained model produce the expected output. So that's the meaning of validation. And after that, we have the prediction. So what's the meaning difference between validation and prediction? So in validation, you have a test data. In this test data, you already have the correct answer actually, but you hide it, and you give the model the problems, and then ask the model to run the problem, to process the problem and give you some output. And then you check with your key answers, is it correct or not? But in prediction, it's totally a new data, the data that the model never seen before. And that will result in prediction. So remember that these 3 steps in supervised machine learning: you will train it, you will validate it, and then you will use the model to make a prediction. Okay, all good? Any question about this? Silent. Okay, since it seems that everybody understands, so we can just go to the next slide. Okay, so this is the machine learning algorithms. As we already mentioned earlier, there are 4 machine learning algorithms: supervised, unsupervised, semi-supervised, and reinforcement. This category, this represents how the model learn. If there is a supervisor that teach the model, it's called the supervised. If there is no one teach the model, it's called unsupervised. And there's also semi-supervised and reinforcement. But we do not really talk about some semi-supervised and reinforcement. We will be focusing more on the supervised and unsupervised here. For the supervised, there are 2 flavors. There are 2 main use of the supervised: for doing a regression and for doing a classification. Today, we will be practicing on how to do a classification using supervised machine learning. There are so many algorithms available for you to use if you want to do a classification using supervised machine learning. There is logistic regression, naive-bayes, KN, k-nearest neighbors, decision tree, and random forest. This is just few of the algorithms that I managed to put in these slides, because if I want to draw everything in the slide, it will be not enough space. So if you are curious and you want to explore more, you can just go to the scikit-learn website. I don't know why it takes so long for my computer to open the scikit-learn website, but you can find there. Oops. Okay, don't open it here. sklearn. Okay, nice. So in this website, you can find there's so many algorithm. sklearn can support you with classification problem, regression problem, clustering, dimensional reduction, model selection, pre-processing, and so many things. And for each task, you can find what algorithm supported by sklearn. Yeah, it takes a long time again. Okay, let's just open a new tab so we will not be disturbing this one page. Okay, see, there's so many algorithm here. Lasso, multitask lasso. There's so many algorithm. To be honest, I have only used few of them here, the one that I will teach you today. So please don't ask me about this all, because I haven't tried yet, but I promise I will try it later. Okay. This is so today we will be learning about KN and decision tree for classification, and also random forest. Random forest will be delivered by my colleague, a very good friend of mine, Mr. Ari, later today in the next session. Okay, so now we will take a look at this simple example. Okay, so regression and classification. Can anybody share a thought about what is regression and classification? Maybe someone, I mean, this is a very common terminology, right? Regression and classification. So I believe it will not be very hard for you to define it. Can I ask a volunteer here? Let me see the list of the participants. How about Kong Pachan, Kong Panya? Are you here? Kong Pachan, Kong Panya? Okay, not answering. How about si Pixai?
Yes, can hear you.
Yes, hello, Mr. Si Pixai. Where are you from?
From Laos.
Oh, from Laos. Nice to meet you in this virtual room. So, could you please tell the audience about what regression and classification in your own word? What you understand about regression and classification? I believe it's a very easy term. So, just share your thought with us. What is regression and classification? Mr. Sipiksa? Are you still there? Okay, I think there's a problem with your microphone. Hello? Or does anyone else want to help Mr. Sipsai? Please don't worry, we learn together here. I also still learning. So sometimes.
Yes.
Oh, okay.
Sorry, I just joined you today, but yesterday I didn't join you. I did not join you. Join about season.
No worries. So yeah. So could you please share us what regression and classification is?
Yeah. I will ask my colleagues about it.
Okay.
My colleagues about it.
Okay. Do you need
And
help from
I will,
other participants?
I will. Yeah, Mr. Wong Pachan.
Oh, okay. Hello,
My
Mr. Wong
colleague,
Pachan.
he also joined.
Well, maybe anyone wants to help Mr. Pacific side and just share your thought about what regression and classification is in your own word.
Can I try?
Yeah, sure.
Okay.
Of course.
Regression versus classification. Regression is more in predicting on the quantity, while classification is predicting on the label itself. Yeah, quantity versus label.
Thank you very much, Farhan. That's a very best answer that I ever heard today. So yeah, so the real difference is the target variable, the Y variable. For regression, you try to predict about a continuous variable. For example, you want to predict how much will the stock be worth. What is this exoplanet's mass? You want to predict about a tall, will this type be as an adult? And so many things. And classification, you want to make a prediction about a categorical variable. For example, in this example, I wrote, will this customer stop, will this customer stop its subscription? Yes or no? Is this mall cancerous? Yes or no? What kind of wine is that? Red or white? What flower is that? Rose, tulip, carnation, or lily? So there is a very vivid difference between those two tasks. And these two tasks can be solved using sklearn. this is the main flavors of supervised machine learning. You use supervised machine learning when you have to do either one or both of these two tasks. Okay, nice. Okay, let's go to the next slide. Okay, so here our first statement. I want you to tell me whether it's classification or regression. Okay, so for the first statement, using labeled financial data to predict whether the value of a stock will go up or go down next week. Is it a classification or regression? Just answer. Everyone can answer. Just jump into this discussion. Anyone wants to answer? I mean, it's very easy question. Actually. Okay, shall I choose the volunteer again? Nice. It's really nice that we have the participant list here, so I can just sacrifice someone. Okay, let me see. How about Huyen from Vietnam? Okay, I will just ask a volunteer here. Anyone? Maybe Miss Ferron again.
Sorry, what's the question again?
Okay, so here are several statements, and I would like to tell us whether it's a classification or regression. So for the first statement is using labeled financial data to predict whether the value of a stock will go up or go down.
Since the value of stock, this is regression?
Yes, but we want to predict whether it will go up or go down.
Oh, okay, go up or go down. So there's two classification here. So yes, it's classification.
Yes, correct. Thank you very much. For the number 2, using labeled housing price data to predict the price of a new house based on various features. So is this classification or regression? Anyone can answer. It doesn't have to be always Miss Ferron. Maybe Lizari wants to share a thought, or Huimin, or Miss Noradila.
Well, it's to predict the price. So
yes,
since it's to predict the price, that is regression.
Yes, correct. Terima kasih. Number 3, using unlabeled data to cluster the students of an online education company into different categories based on their learning styles. See, we have the keyword unlabeled data here. So maybe I will ask you, is this a supervised or supervised machine learning?
It's to cluster the students, then it's unsupervised learning, right?
Yes.
Unsupervised.
Yes. See, the keyword here is the unlabeled data. So you do not teach the model. You ask the model to think by itself and just give you the answer. Okay. Number 4 is labeled financial data to predict what the value of the stock will be next week. Yes, this is supervised, but is this classification or regression?
It's regression.
Regression supervised.
Yeah, betul. Thank you very much. That's correct. Okay, so since you already got the gist of the difference between classification and regression, so it's safe for me to jump into this, the machine learning workflow. Okay, so you already know the task, so let's see the machine learning workflow. Well, actually, I already mentioned about it earlier on the slides, on the presentation. So when you decide that, okay, it's time for me to start using machine learning, you have to know the workflow first. So what do you want to do at the beginning of your journey with machine learning? First of all, you need to have your data, of course. I mean, what machine learning is without the data? So you need to load the raw data. Get and load the data will be fulfilled using pandas. In our hands-on, we will use the function read CSV because Pandas is very handy in handling input and output API. So but let me see this one, open it. Okay, so this is the input and output that are handled, that could be handled by Pandas. You can see that there's a read table if your data source is a table. There's a read CSV if your data source is a CSV. There's also many other options like with Excel or with JSON. So it's very handy. You just have your data and ask Pandas to help you for data loading. So I would like a volunteer to try it. Anybody wants to try? Has anybody downloaded the IPYNB file from the Google Drive? Let me see. Have you downloaded this? My dear participants, my dear colleague. Have you downloaded this? Anyone has downloaded this one? You want to try to do a data load. I mean, you can just read about, okay, I can load the data using Pandas read CSV and you can read the documentation, but the best thing in really mastering something is really to get your hands dirty on that. So let's do it together, but I would like you to type it instead of me. I already provide the script, but I just need you to, wait a minute. So here it is. So you can see that there is a blank here, and I would like you to fulfill it. Anybody wants to participate? It's very easy because we will solve it together, but I just want to volunteer from the participants to try it. How about
under SPD?
Yes, I mean, would you like to try it? You can share your screen. I mean, open this one and then share your screen, and then together we will try to fill in the blank. Have you ever used Pandas before, Nora Adila?
Yeah, but just for self-learning only.
For what? Sorry.
Self-learning.
Oh, okay, self-learning. Yeah, so I believe that you ever tried this one before, loading the data from CSV using Pandas?
Yeah.
Okay, so it will be a very easy task for you. So would you please share your screen and then show our other friends on how to load the data using Pandas? I will accompany you in filling this one. I will tell you what you should type if you forget the syntax. Would you want to do that?
Okay, just give me a minute. I will share my screen.
I will stop share first.
Okay, I cannot share the screen until the.
Oh, we should ask Mr.
Sueka
Sueka.
to. Okay. Okay, now I can.
Dibantu, Pak.
Okay.
Okay.
Everybody should able.
Oh, okay.
Now I can share my screen. Can you see my screen?
Yes.
Yes,
Okay.
you can see.
Okay. So the first thing that you have to do is importing the library, and our library name is Pandas. So you have to type Pandas as this is a nickname for the libraries. Mostly people use PD as the library. Yes, correct. Thank you very much. And then, okay. So that's importing library. You are not loading the data yet. Okay. So let's go to the next line. The df equals to PD. Okay. You don't need to run it right now.
Oh, yeah?
Because we need to fill in the blank for all the lines inside that cell. Okay. So yeah, you see there's an error. Model has no attribute. Yeah, because we haven't fill all the blank for that particular cell. Okay. So the next step is you have to do a read. You have to call the read. Let's see that the data that I provide to you is in CSV format. You can read it in the comment, the green letters right above that line, the github.com Ericaris. So our data is income evaluation.csv. So you have to read this, and pandas provide you with a function named read CSV. So maybe you can open it, read CSV.
Open the URL.
Yes, but you have to type pd.readcsv. Okay, read_CSV_CSV. Yeah, there's a suggestion from Google Colabs. Thank you, Google Colabs, for helping us with that. Okay, so now you have to define what's the name, the file name. So I already provided on the line above. You just need to copy and paste https://github.com, yeah, until the last single quote, including the quote. Okay, so you have to enclose it with a single quote or double quotes. That will be fine too. Okay, now you already loaded, but you want to prove that you really loaded, so you have to preview the data. In Python, you can use the head function. So you just type df.head. Okay, you have the extra underscore, okay, head, and then inside a parenthesis, put a parenthesis, head, okay. Inside the parenthesis, please define the number of rows that you want to see. For example, if you want to see the first 5 rows, then type 5 inside the parenthesis. Okay, now it's safe for you to run it. Let's see the result. Yay, congratulations! You have successfully loaded the data and you managed to preview the first 5 rows of it. What if you want to see 10 rows instead of 5? It's easy, just change 5 into 10. Run it. Okay, congratulations, nice. So that's how to load the data. Now you have a data ready in your machine for further use, for exploring and for modeling. Terima kasih, Noradila.
Okay, welcome.
Okay, please, other participants, please also do try this code too. So you can keep up with the pace and do not left behind during this course. Okay, now I will take over the screen. Here it is. Okay, so we have successfully working on the first step, which is loading the data. And then the next thing to do is to extract the features and get familiar with your data. Because you cannot do anything with the data unless you understand it, unless you know the columns inside of it, you have a general idea about the distribution, for example, and whether it has missing values or not. So you have to get familiar with the data. We will try it here. So here. See, as this person said, that one does not simply dump raw data into machine learning algorithm, because that will produce a very garbage model. So we need to do some exploring, cleaning, and pre-processing. For exploring, we can still use pandas, that's very useful library. You can use the function head, info, describe, columns, shape, rename, and isnull is a function to check whether you have missing values or not. And then after that, you can do a cleaning and pre-processing, such as handling missing values, bucketing, standardization, normalization. This will be handled by sklearn. So don't worry, pandas and sklearn get you covered. So all you have to do is just type it without really considering about the complexity and computation behind it. Okay, anyone wants to be a volunteer for this exploration and cleaning and pre-processing? Who else wants to be a volunteer? We already have Nadila as our first volunteer to try to do the reading data from CSV. For exploration, I need another participant. Oh, we only have 7 participants left. How about Hui Min? Do you want to be a volunteer and trying to run the script? We lost Miss Farron. Where is she? Maybe there's a problem with her internet connection, I believe.
Miss Farron has something to do, so she need to leave the lecture room.
Okay, that's fine. That's fine. So anybody else wants to try with the code? How about Huyen or Rachel? I'm just mentioning everyone's name here. Please do not leave the room just because I call you out. Hung from Vietnam, or Hung Pai Chan. Okay, so maybe Noradila, do you still want to try it and become our very dear volunteer?
Sure, can.
Okay. Okay. Thank you very much. I'm so lucky that to have you here in this course. Otherwise, it will be a very silent course. What's the interesting thing in that? Right.
Explore the data, right?
Yes, you can share your screen.
Can you see my screen? I have shared my screen.
Not yet.
Not yet. Let me try again. Okay.
Okay. So the first thing that you want to do is to check the shape of your data frame. So the data frame is a terminology used by pandas. It's analogous to a table or a sheet in Excel. So it consists of rows and columns. So do imagine data frame like a table. So you want to see that the shape. So you can just type df.shape. Okay, run it. Okay, so there you can see, so the output is the row and column consist in the data frame. So from that output, you can see that you have 32,561 rows and 15 columns. So you can have the general idea of what your data right now. And then you want to have a further exploration by looking at what columns do I have in this data. So you just need to type df.columns. Run it. Okay, so that's the list of columns available in your data. You can see that you have age or class, MNL, weight, education, and so on until the income. Okay, now the next step is you want to see, wait a minute. Columns names. Okay, so the next cell is try to remove the strip in the column names, because you see that we have, for example, like, yeah, something like that, and you want to strip it. Strip it means to remove the white space. You just need to run the next cell. You don't have to filling anything.
Error.
There's no attribute map. Okay, wait a minute. Let me see. Do I miss? Wait a minute.
No attribute map.
Yeah, I think we forget to import something here. Wait a minute. Okay, yeah, change the map into rename. Sorry for that. But it's good that you got an error. It means that next time you will remember, oh yeah, I got an error about this, so it's rename. Sometimes you can easily remember something when you find an error. And that's the art of doing coding. And okay, so Okay, you can run the columns again and see if you manage to remove the white strip.
Yeah.
Okay.
There's no more white space at the front.
Yes. Okay, good. Looks good. Okay, so to the next cell, you want to check the null values and count the number of missing values of the target variable. So for this, you will use is null. It's null is and ull. Wait a minute.
At the front.
Yeah, at the front, df that is null, and with a parenthesis. Okay, so there's a and after that, you do not only want to see the, okay, you can just run it actually. Just run it first and then see. Okay, so it shows you if you have a null values or not. False mean that for that particular cell, there's no null value. So right now you want to see how many null values that you have. You can just add more syntax after is null. You can just type dot and then sum.
But then
Sum, S-U-M, yes. With a parenthesis.
oh sorry.
Okay, run it. Okay, so you do not have any null values, fortunately. Luckily, you do not have it. Okay, the next cell, another step of exploring the data is you want to see the descriptive information about the data. So you want to use the describe function. So you can type df.describe, yes. Run it. See, you got the count, mean, standard deviation, minimum, and the quartile and max values for each column. It will be really useful for your next analysis, I believe. Okay. The next things to do is, this is a very long process actually, because you know that pre-processing takes so much time from our in our data processing world. I mean, analysis or maybe running a model will be nothing without prepare your data properly. So pre-processing is a very important step. Okay, and then you want to checking the target variables. For the target variable, so can we go back to the df.columns? Oh, you stopped sharing.
I'm sorry, my screen is.
Yes. Can you share your screen again? Okay. Okay, so let's see the list of the columns that we have. You can scroll up. Push here, please. Okay, scroll up again until you find the list of the columns that we have found earlier. So that's it. Okay, so we have age, work class, and other columns. So the target variable that we want to use is the income column, and the other column will be used as the features column, or if you imagine the regression equation, it will be the X variables. So we will use income as the target variables. Okay, let's go down. Sorry to keep you busy, Noradila. I hope
yes,
you
okay.
mind. Okay, so you just need to type df.income. So in pandas, if you want to access one particular column, you just type your DataFrame name dot the column name. So if you want to see the income column, you just type df.income. And after that, you can chain the script with other function that you want to do. For example, like you want to count the value inside of the column income, you just type df.income.value counts. Okay, just run it. Okay, so there you got it. So the income column consists of labels actually. It's income less or equals to 50K and income more than 50K. And from that, you can see that this is like the percentage. It's like the percentage of the data. So you can see that 75% of your data is labeled as less than 50K. Okay, now the visualization, because in exploration it's really important for you to have a visual of it. So for this, we will use another library. It's called matplotlib. I already imported for you there. Import matplotlib.pyplot.stlt, and then you just need to run it. You can see that from the script, we type the kind of plot is bar. We define the plot is bar. Plot kind equals to bar. It means that we want to have a bar chart. So you see that this is the visualization of the data. So most of our data consists of the data labeled as income less than 50K. Okay, nice. Okay, so now we want to separate all the categorical columns together. For this, you just need to run it. I do not remove anything from it because I don't want to waste so much time. We have a very limited time. And for this, you want to, you just need to run it. It's just want to check the numerical variables. Just run it. Yes, that one. Okay, that's your columns, which is a numerical type. And then the last one is you want to check the unique values and their counts in each categorical variable. See, you have the data. So for sex, the male, the female, and for native country, you have the value. So for each column, you get the unique value for each column. For example, for native country, you have United States, Mexico, Philippines, Germany, and the second column represents the percentage. Do you see anything interesting from that?
It's the question mark.
Yeah, there's a question mark. And
it's actually missing, right?
Yes, and we will solve it later. We will handle it later. Okay.
That is why we have no count of ISNA.
Yes. Okay. Okay. Keep scrolling down. Keep scrolling down. Okay, so that's the question. Is there any interesting things that you see from the output above? Yeah, you already answered it. The question, the country that is labeled as a question mark. We will take a look about it later. Okay, now we want to visualize it instead of just creating a list of it. So we just run that cell. Okay, now you have a bar chart for each column. For example, for marital status, yeah. So for example, for work class, you have what is that? State gov, private, local gov, and so on. But with this bar chart, you can directly see for work class column, what value do I have the most? So for work class, for example, you have most of your data is a private, and for education, for example, could you please scroll down? Okay, for the education, mostly your data is a bachelor of what is that? Grad, and then some college and things like that. So it's really easy for you to have a more clear information about your data when you visualize it like this. Okay, could you please scroll down? Okay. Please bear with it because preprocessing is really tough actually. Okay. Now we have the bucketing. Okay, so you are done with the data exploration. Now you want to do a bucketing. Bucketing means you want to bucket the categories together, which values is very, very small. So we will categorize it as others. Okay, so for the first cell, you want to categorize column that have a very small values into the word other. Can you just run that cell? Okay, so you see that we define a variable check in a bracket, which consists of values that gov, self-am, inc, federal gov, without pay, never work. This is value that we see from the bar chart, the previous bar charts, and we know that this value has a very small amount of data, so we want to group them together and label them as others, because we do not think that it's interesting enough to present later. Okay, so you have private self-M, you get that result. Okay, different class, assigned work class, others. Okay, we still have that question mark data. Okay, keep moving, keep scrolling down. We have also education. Okay, so you need to fill the blank actually, but it's just, you just need to copy and paste from, you just need to copy it from the previous cell, because we work on education, so the column name is education instead of work class. Okay, have you managed to? Don't forget to put it inside of quotes, the name of the column. So inside of DF education, yeah, you need to put it inside of single quotes. All right, and for education, you can do the same thing too. Okay, and now you want to do the same thing too for the marital status. I think I, okay.
What is the, I need to see the name of the marital status. Wait, I have dash.
You can also check the bar chart actually. The marital status is marital dash status inside a single quote. Okay. Okay, and also do the same thing for the occupation. Other participants, can you also try it at home at your place? All right, copy and paste. And also for the race. And native country. Okay, nice. And the last one is replacing the quote, the question mark column. Okay, so we will do it by first we will replace the one with the question marks with others. So yeah, so the replace means that all that is written as question marks, replace it with the words others. It's very easy, right? So run it.
To see it again, DF. Dot, forgot.
You can do that, maybe just df.hat and just take a look at the first 5 rows that you have. Okay, run it, and you're good. Okay.
If you want to see the whether the question mark is still there or not.
I think you can run the code that we ran earlier. The one with the, take a look at Wait a minute. Where is it? Where is it? Yeah. Okay, maybe that native. Yeah, that one. Okay, let's see if we manage to still there. Oh, is it not?
I think that one we just change it to others, but we didn't save it to the table. Or
Oh yeah, I think we need to put a word in place so it will change to the. Yeah, I think we need to save it. Yeah,
yeah, I think this one you just replace the label the cell without saving the.
The F4 class, the affiliative country. Let me see. I think we should put the word the in place parameter. So yeah, you're correct. I think we have to save it. Not that one. Replace, but wait a minute. Let me try to find unless replace. Okay, yeah. So after the word others, you should add one more parameter, which is in place equals to true. So it will replace, it's not just replacing in memory, but it's replacing it in real.
Dot in place equal to true, right? This one?
And no, it's still in the parentheses. So after others, okay, that's right. By default, it's false. That's why you do not. It doesn't change the value. Okay, try to run it. Then true. Wait a minute. The true is a capital T. You use the capital T. Yes. So Python is a case sensitive. If you type it in the wrong way, it will throw an error. Okay, let's try to take a look at the previous code, whether we managed to destroy the question mark value. Okay. Okay, where is it? The native country. Where's the native country?
This one, right? So there's no more question mark, right?
Yes. Okay. Okay, so we successfully remove the question mark. And now the next step is numerical column analysis, but I think we can skip it because of the timing. I don't want to consume too much time for this. Numerical column analysis is basically just try to show you the descriptive analysis, just like what we do earlier with the DF, but instead we just want to do it per column, for each column. Okay, well, there's actually so many steps left, like creating dummy variables, but I think we need to skip it because it's already 9:24 Jakarta times. So maybe just skip it. How about we just skip it and go back to the material? I will show you the complete code later, so you can try it at home. Let me see.
Should I stop sharing my screen?
Yes.
Okay, thank you.
Thank you. Okay, I think I will try to share the complete script because I don't want to consume too much time. Give me a minute. All right. If you could go to the Google Drive, you can see that I already uploaded a new one, a new script. This one is the complete script without the fill in the blank thing. So you can try to run it by yourself, because I believe that learning learning like what we just did earlier is very fun, but it's consumed too much time. So okay, let's just try to run the complete code. Okay, so let's just go back to the slides, shall we? Because we need to finish the material. Okay. Okay, now we go back to this one. Okay, so you managed to extract the features. The next thing that you have to do is to split the data set. So after you explore the data and do some pre-processing, cleaning, you need to label the data. Labeling the data means that you will make a notation like this. For example, heart disease, is it true or false? So if you have these features like this, age 55, sex male, and so on, you want to label it whether it's it's got a heart disease or not, true or false. Have your data already annotated like this, but sometimes in real world you will have a data without labeled like this, so you have to invest your time to labeling the data first. Then after you finish labeling the data, the next step that you have to do is splitting the data. You split it into two: the trained data set and test data set. So what's the goals of doing this splitting? Doing the splitting means that we'll use the trained data set to train the model, and we will use the test data set for evaluating the model. So the test data set should be something that the model hasn't seen earlier, so the evaluation result will be more precise. So this is the illustration of doing the data splitting. Well, actually, I already prepared the material here. But since I believe that we don't have enough time to run all the codes, so I will just show you about how to do it using sklearn. Okay, there's the check here.
Anyway, don't worry, Erika. For my part, I only need just a short time, so you can use so much time. So don't worry.
Thank you, Ari. Okay, so this is the splitting the data. To do it using the Google Collapse. Okay, let's use this. Maybe I'll just try to show you the code to the data splitting, the train and test split. So using sklearn, you only need to import the data, import the library. So this is the code, sklearn.model selection and import train test split. And after that, you will use the train test split function. You will define how much of the data that we'll use as a train data set and how much that we'll use as a test size. So in here, it means that I will use 70% of the data as a train data set and 30% of the data as a test data set. And then you just need to run the data, to run the code, and you got your train data set and text data set. And we will put it inside this variable. All right, so let me run this. For those of you who has download the code from the Google Drive, try to run all, so it will really save your time later while try to listening to keep up with the material. Okay, so this is the train test split. And after you have, the next step that you have to do after you having your train and test data set is to train the model. Let me go back to the workflow here. You need to train the model. So training the model is basically you inputted the trained data into your machine learning model and outputted a trained model. Okay, back. And after that, you will do the evaluation. You will use your taste data set and then you feed it into your trained model. And you see the result and you will calculate the accuracy. What accuracy means, accuracy is a measure how much of the prediction is actually correct. So this is the flow chart. This is an illustration of how to do a test and evaluation. In here you have a trained model and then you trained it using the test data set and you calculate the performance. Is it good enough or not? If it's yes, then you're done. You're golden. You have your trained model. But if it's not, then it means that you have to turn it and retrain it again until you reach a good enough performance. So for the train and testing the model, the mantra is fit and predict. So training means that you will use the fit function and test means that you will use the predict function. I will show you in this code here. So here we have this one. This is for example, if we want to run a decision tree classifier, you will use the fit. It means that we train the data and after that we predict. So as simple as that. I mean, if you learn the algorithm, you will find so many complex calculation behind it, but using sklearn, all you have to do is just fit and predict and then calculate the accuracy using the provided function. So it's very easy. Okay, we have finished this one. Look at your trained model. So this is the evaluation, it's computing accuracy. And there are two issues that you could find when you're evaluating the model. It's overfitting or underfitting. Overfitting means that your trained data match almost perfectly, has a very low error, but when you fit it into a new data, it will have a very high error. And underfitting means that you have a very high error. It's failing to capture relevant patterns. So to solve this in KNN, it depends to the algorithm that you use, but for KNN, you can try several different K and choose the one that produce the lowest error. And for the decision trees, you can try several different max not leaves and choose the ones with the lowest error. This is a matrix that you can use when you try to evaluate your model. For regression, you can use mean absolute error, root mean squared error, coefficient of determination, R-squared score. And for classification, you can use accuracy score or classification report, which consists of precision, recall, and F1 score. And also you can have a confusion matrix. Well, actually, all of these metrics are already provided by the sklearn metrics. So yeah, again, you just need to run it. Okay, so this is the example of confusion matrix. Has anyone seen confusion matrix before? Maybe Katsana Homa Hong? Are you there, Katsana? Do we still have you in this room?
Maybe it is the matrix that make us confused.
Oh.
So it called as confusion matrix.
Yeah, I just want to see if anyone has seen this table before, or maybe Noradila.
Yeah, I've seen this. Yeah, I've used this confusion matrix before.
Okay, that's nice. So it will be easier for you to understand it. So we will have for quadrants here, we will have true negative, false positive, false negative, and true positive. True positive means that you predict it's yes, and the truth it says, so it's good. True negative means that you predict it is no, and the truth is also no, so you predict it correctly. False positive is when you predict it as a yes, but the truth is no. And false negative is when you predict it as a no, but the truth is yes. And this is the formula for accuracy, precision, recall, and one. It's really useful if you want to be a machine learning engineer or machine learning expert. So you need to really understand about the formula. But again, if you want still learning it, I mean, if you are a beginner and you don't want to be intimidated with all of this formula, just run the metrics from sklearn and it will give you the result. But of course, it's also still really important for you to understand it. So when you have to provide a description or analysis, you can give your argument about the reason behind the metrics. And after you finish the evaluation and you think that you have a good enough performance, you have a ready-to-use model, and you can feed a new data into the model, for example, like this, and then you start doing your prediction. So for example, like when I use this new data and I feed it into the model, I get the result that, oh, this is false. So this is not a hard disease. Things like that. Okay, now we have come to the next section, which is the K nearest neighbors, or KNN in short. This one is the algorithm that we use for classification in supervised machine learning. So the idea behind KNN is very simple. It's very intuitive. It's follow the saying, birds of a feather flock together. So if you're confused to which group you are belonged, you can just take a look at all the people around you, and you see what people and you just choose the group of the people that is closest to you. So that's the basic idea of K nearest neighbor. So the motto is the closer, the more similar. So if it's more similar to me, I will just join that group. Hence the terminology, the nearest neighbors. So the K here is a variable. So it is the number of your neighbors that you will consider to classify yourself into which group you should belong to. Okay, so this is the illustration of K nearest neighbors. Okay, so let's imagine that you are this orange square and you are confused to which group you should belong. Are you a category A or are you category B? So the first thing that you have to do is selecting K number of neighbors that you want to consider. For example, in this illustration, we choose to use the K 5, it means that you will consider 5 neighbors around you, the 5 closest neighbors around you. And then you will do a voting. So among these k neighbors, count the number of the data points in each category. So, okay, so the green one, there are 3 green people and 2 blue people. And you will do a major votes. Major votes means you will choose the one that has more members. So in this case, to which group do you think you should belong? Anyone can answer based on the explanation. Maybe Mr. Sikpiksai wants to answer it. Mr. Sikpiksai, you can also answer.
Yes.
Okay. So,
Yeah, thank you. Sorry, I cannot answer now.
oh, that's fine. That's fine. Maybe other people.
Maybe my colleagues can answer you.
Okay.
Kesana, oh, yeah. Next time.
Yeah. Do we have Rachel here? Rachel from Philippines. Hello, Rachel. Or maybe Huyen from Vietnam. Don't be shy. It's very easy. I just want to know, according to this illustration, to which group do you think this orange circle should belong to? Should it join the green group or the blue group? Or someone wants to answer? Anyone? Okay, maybe Miss Noradila want to answer.
Yeah, we just
save the day.
I will just try. Since it says that compute the distance of each neighbor to our new data point, so the distance is ascending order. So it will, can I say it belong to category A?
Yes, correct. So the most reason, so the reason why it should belong to the category A is because the category A has more members than category B. More members here means that you choose 5 nearest neighbors. So from this example, this orange guy choose the closest 5 neighbors around him. And then from these 5 neighbors, he take a look at which group has more members. So you see that category A has 3 people from the chosen 5, and the category B has 2 people from the chosen 5. So since A has more people inside of it, has more members that from the 5 neighbors that I chose, for example, I will just join the green one. So that's the basic idea behind KNN algorithm. I hope it will give you some illustration. I also provide this one. This is I think it's a more intuitive illustration about how the KNN algorithm works. See, when we have the, okay, let me see. Okay, so distance computation. So these white guys measure its distance from all the neighbors around him. Okay, and then when he chose the neighbors, only one neighbors, it will certainly means that he will join this orange group. Okay, now he chose 3 closest neighbors from him, and since from those 3, 2 are oranges and 1 is yellow, so he will choose to join the orange group. Okay, now he chose 5 closer neighbors. So you can see that out of 5, 3 are orange and 2 are yellows. Still, 3 is bigger than 2, so these white guys will consider to join this orange group. Now let's say that he wants to choose 7 nearest neighbors from him. Now you can see that only 3 orange people and there are 4 yellow people. So to which group do you think the white guy should belong? To the orange group or to the yellow group? Anyone wants to answer? Maybe Fong Pachan, Fong Panya? Mr. Fong Pachan? Would you like to try to answer? Well, it's actually the answer is literally there on the screen. You just need to read it. Or maybe again, or Adila.
Sure. So since it's 3 orange and 4 yellow, then it goes to yellow group.
Yes, because it follows the majority. Thank you very much, Adila, for always there to save me.
Sure.
Okay, now the white guys choose the 9 closest neighbors from him. And we see that right now there are 4 orange people and 5 yellow people. So according to the major fault rules, the white guy will choose to join the yellow group. So that's how the classification is conducted using the KNN or K nearest neighbors algorithm. I hope it will give you some idea, especially after seeing that video. Okay, let's go back to the slides. Okay. So one major issue in KNN is try to choose the right K, because as you have seen before in the video, choosing different K could result in different classification. You see that when he chose to use only 5 neighbors, he belongs to the orange group, but when he chose 7 or 9, he has to join the yellow group. So what is the correct K that we should use? The only way to do this is just to try several K value. For example, like you see here in this graph, we try the number of K for 2, 4, 6, 8, 10, 12, 14, and then we calculate for each K, we will calculate the accuracy or the error that it produces, and we will try to choose the one with the most stable, the most stable one. The most stable one, it means that it has a low test error and also not so high trend error. So from this graph, we can see that since the train graph and the test graph meets around here, that it is safe to say that it's that the choosing 8 per K is the best choice for us. So when you have a data or a graph that looks like this, then choose 8 neighbors for your algorithm, because it will give you the most tables output. Okay, now let's try to take a look at the code here. Okay, for the KNN, all you have to do, so I think the step is very easy using sklearn. All you have to do is just import the library here. Since we want to do a classification using KNN neighbors, so you import the K neighbors classifier, and then you instantiate it, and then we use n neighbors equal to 9. Anyone understand what does it mean? What does it mean that n neighbors equals to 9? Just feel free to open your mic and then answer the question. What does it mean?
So we will measure 9 nearest neighbors.
Yes, correct. So what if you Noradila, wants to use, let's say 15 neighbors, what you will type in here? If you want to choose 15 neighbors instead of just 9.
So n neighbors equal to 15.
Yeah, so you just change 9 to 15. So as simple as that. And then you train the data. Train the data. Remember that I mentioned earlier the mantra. Where is it? Okay. Okay. So fit and predict mantra. Fit means train it. Predict means to test the model. So here you can see that. Okay, I think I need to zoom it in. Okay. So here you can see that. Oops, it's too big. Okay, so here KNN dot fit X train Y train means that you want to fit you want to train the data using the X train and Y train. Because remember when we split the data before it in here, we save the data into X train and Y train. This is a train data set, and then X test and Y test. This is the test data set. So using that splitted data, so you can just simply input fit the data set into the fit function, KNN.fit. So just run it, and it will, and you're done training your data. That's easy, right? Just using this 2-line code, you're done fitting your data. And after that, you want to do a prediction. This is actually try to evaluate the data or taste the model. I mean, using the taste data set, you just need to do KNN.predict. So you have KNN.fit to train the data, and then KNN.predict to test the data. And now you use the X test. So you see the difference. For the fit, you use X train and Y train, and for the predict, you use the X test. Can you explain the difference? Why do we use X train, Y train here in the fit, and we use X test in predict? Anyone can answer? Maybe Miss Rachel from Philippines, if you are there and if you are willing to participate in this discussion. Okay, the same silence. So I think I will need to ask your help again, Noradila. Please don't leave the group.
So X test is the whole sample that we use to validate the train that we have done.
Yeah, my question is, why do we use X test here? And why do we use X train and Y train here? Oops. Okay. Why don't I just type like this? KNN dot fit X test Y test. Maybe you have some intuition about why it is this way.
Because actually I'm not thinking that because we always use the X train to fit train sample to fit and the whole sample to predict, to validate. So I'm not sure why I didn't think about why we didn't use the X train there.
Okay, so remember the fit and predict mantra here in the slide. Train means dot fit and test means dot predict. So sklearn has saved us a lot of time to do a training and testing the data just by typing the dot fit and dot predict. So when you want to train the model, it means that you want to fit it into the model. That's why you use X train and Y train here, because this is the train data set that we have created earlier. You see in the previous code, the train and test split, we have divided our data. So after loading the data, the ones that you did earlier with the income data set, you will split it into 2 parts. 70% of the data you will allocate it as a train data set, and the rest 30% of the data you will use as a test data set. Because let's go back to the workflow here. Because when you do a machine learning, you need two different type of data set, train and test data set. Trains is to train the model, to teach it, like when you want to say, like when you want to show the model, this is orange, this is apple, this is banana, this is watermelon, for example, and then you will have a test data set. This is a new data that you haven't that the model hasn't seen before, so that when you evaluate its accuracy, it will give you a trusted value of the accuracy. I mean, if you train the model with a certain data set and you will test it with the same data set, it will be meaningless, right? Because you test it with the same thing to which it was taught. But when you evaluate the model using a new data set, using a different data set that the model hasn't seen before, then you will really sure that, okay, the model can really distinguish between banana and apple, for example. So that's the answer.
Sorry to interrupt, but the name of the data set is not necessary we need to put train or test, right? Because what I mean is, if I put feed X test at the feed program, then it's still running, right? Because it's just matter of the name of the data set, right?
Yes, this is just the naming. I use this because it will be easier for me to memorize. Okay, X train, it means the X for training. X test, it means that X for training. You can just type in another word like, for example, X real or things like that. It can still also learn. It can also still work, but I just need to, I don't want to be confused because it will be easier for me to get confused. But it's really up to you what variable names that you want to use. But the good tips is to try to use a valuable, a meaningful name, the one that will not confuse you later in the future. Okay. Okay, so that's the answer why we use X. Wait a minute, which one did I open earlier? Okay. Model building. Okay, this one. Okay, so I hope everybody already understand about why we use .fit with X train and Y train, and why we use the .predict for the X test. Because in here, in this cell, we try to train the data. That's why, of course, we need to use the train data set. But for prediction, we want to use the taste data set that we have provided, that we have prepared earlier. So I think I will just delete it. Okay. And then after you train the data, you predict the data. After you predict the data, it means that, let's just run it and see how it goes. It's updated remotely. Okay, it will take several times, but after you predict it, you can just wait a minute. Okay. We got the result yet. Okay, I think we done doing the prediction, and we can see the result of the prediction. So this is an array actually, but it actually display the result of the prediction. So when you give the model X test and ask the model to predict the result, it will give you this one. And then you want to evaluate the result by comparing it with the real result. So remember that when you try to split the data set, you have, wait a minute, where is it? Okay, this one. You have X test and Y test. So y-test is the correct output of the x-test. And you use this x-test and you give it to the model and ask them, try to use this and give me some output. When the model give you output, you compare it with the y-test here, the real answer of the x-test, and you calculate how many prediction that the model missed and how many prediction that the model can conduct correctly. And after that, you compute the accuracy using the metrics that I mentioned earlier in the slides. And if you feel like, and if you manage to achieve a good enough performance, let's say you manage to achieve 80% of the accuracy, then we can say that your model is safe to be used for future prediction, for a real prediction using a new data. Okay, that's for the KNN. So you see, this is fit and predict, and this is the confusion matrix. This is a classification report. This is just the evaluation report. Maybe we just skip it for a while and then go back to the slide because we still have one new material, another algorithm that I want you to learn. This is the decision trees. But I believe that you can try to run it later after the course if you want to get more understanding about this. Okay, this one. Okay, now the next algorithm is the decision tree. This is also for classification. Decision tree is very intuitive. If you are someone who is familiar with reading a flowchart, and I believe that you will have no problem in understanding it. So, for example, that if you want to make a decision about a certain job, about a job offer, you want to check if the salary is higher or not. If it's not, then decline offer. But if the salary is higher than your current job, then you want to consider another fact. Can you walk to the office? If it's no, then you decline the offer. Done, stop here. If it's yes, then you want to check if it offers free food. If yes, then you accept the offer. If it's not, then you decline the offer. So that's the decision trees. I believe that maybe all of you have seen it before at one point in your life, maybe when you were studying or maybe when you have to finish a job. So before understanding the algorithm behind decision tree, you have to understand the decision tree terminology. So this is called root nodes, and this one is a branch, and it has nodes, and the final output or the final label is called the leaf nodes. So a decision tree simply asks a question, and based on the answer yes or no, it further split the tree into subtrees, as you can see in this example. Okay, so this is the algorithm of how decision tree works. So you begin with the root node, and then you will start to splitting the tree based on a column. So for example, if you remember the data set that we have loaded earlier this morning, we have the income data set. You want to split the data set into two groups based on certain column. So this is the challenge actually. Which column will you use to split the tree? Whether you want to use the education or marital status or country. So which column should you use? So there is a method to solve this. It's called the attribute selection wizard, which is, so you can either choose the attribute using the information gain or the Gini index. So information gain means how much information a feature provides about the class. The higher information gain, the more preferred that column to be used as a splitter. And Gini index is the measure of the impurity of the features. The lower Gini index, the more preferred that column used as a splitter of the tree. And then after that, you split the tree based on that certain column. For example, after you compute the information get and or Gini index, you find that education provide the most information about the data. Then you will use it as a first splitter. So you split the data into two groups based on the education. And then after that, you recursively make new decision trees using the subset of the data set created from. So you just repeat the same activity again until you cannot further classify the nodes. It means that you already arrive at the leaf nodes here. I believe that it sounds very complicated and it's really confusing for you, but don't worry, as I write here, worry not, because all handled by sklearn, including calculating the information gain and Gini index, because if you want to compute it by hand, you will take so many these frustrating days to calculate everything. But since we have sklearn, so just save your worry and use sklearn, because sklearn already compute everything for us. So all you need to do is just fit and predict. So remember the mantra, fit and predict and evaluate. Okay, so let's try it. We go to the script here. I already prepared the model building with decision tree. See, first thing that you have to do is similar to the one that you have done in KNN. First thing that you have to do is just importing the library, the decision tree classifier, as you can see here. So when you use KNN, you import K-neighbor classifiers. And when you use the decision tree, you import decision tree classifier. See that sklearn is really kind to us, because it created a function whose name is very intuitive. It's very intuitive for us. I mean, like decision tree classifier. Oh, it means that it's this is a function to do a classification using decision tree. And K-neighbors classifier. Oh, it means that I have to use it if I want to do a classification using KNN. So okay, and after that, again the same steps. You instantiate the classifier, and then just do the fit and predict. Fit and predict, and you see that we use X-train and Y-train for fit, because for training we use the train data set, and for predict we use the test data set here. And after that, you just run it and you got your prediction. And the same with KNN, you will try to evaluate the accuracy by using confusion metrics or other metrics that is provided by sklearn. And you can also visualize the graph. Sometimes it takes too much time. It's still running. While waiting for it, I will just go back to the slide. And this is the example of decision tree that I find really related to the course that we taught today, because it's the decision tree of algorithm summary. So you see, this is the function that is provided by sklearn. So we start from here. This is the root node, and we ask ourselves a question: are our samples more than 50 or not? If it's yes, then you go to predicting a category. If it's not, then you have to get more data. So if you are predicting a category, then you go to the next question: do you have labeled data? If you do not predict a category, you're predicting a quantity. And then if it's less than 100K samples, you use the NVD regressor. If you have few features should be important, you can choose either to use elastic net lasso or rich regression. So yeah, this is very complicated. I don't want to bore you with all of these terminologies, but I would like you to get the idea of decision trees. Even decision trees is really useful when you want to decide which algorithm do you want to use for your machine learning task. So you see that do we have KNN here? Yeah, here it is. K-neighbors classifier. So you use it when you have labeled data and you have less than 100K samples. and then linear SPC is not working, and you do not have text data, then you can use this. That's the example of decision trees for deciding which algorithm that you use for your machine learning. Let's see if it's already finished running the graph. Yeah, this is actually the graph. Since we have so many data, this graphs looks doesn't make a sense. It looks like it's not really useful. But if you have if you have a smaller data, then this will show you the trees. You see that this is a very small image. This is because we have so many branches and leaves. So the Python only show us this. And the depth of the tree is 57, so it's really depth. We have so many branches. Okay, let's go back to the slides again. So this is the pros and cons of using decision trees. The pros is it's easy to understand because it's very intuitive. It's follow our intuition in making a decision. It's very useful for solving decision-related problems. It can handle both numerical and categorical inputs. It's robust to outliers, and it's fast for large data sets compared to KNN, for example. But it also have some cons. It could be really complex, especially when you have so many features, because more features means more layers, and more labels means deeper tree. So it could be really complex as the data that we have here. It's a very complex data. We cannot even visualize it properly because it confuses us even further, the visualization. And it may have an overfitting issue, which can be resolved using the random forest algorithm, which will be delivered later after my session. Okay, and this is the two takeaways from my talk today. For supervised machine learning, just remember that there are two flavors, regression and classification. And remember this mantra, fit, predict, and evaluate. So for training, just use the fit, and for testing the data, use predict. So just remember fit, predict, evaluate, fit, predict, evaluate, fit, predict, evaluate until it becomes the part of your life every day. Okay, this is some implementation, real-life implementation of machine learning in NSOs around the world that I happened to read before. For example, like in US Census Bureau, they use machine learning for automatic product categorization. So what kind of algorithm it is, you think? Automatic product categorization. Is it regression or classification? Anyone can answer? Maybe Nguyen from Vietnam? Nguyen, are you there? Or Katsana? We have so many people from Vietnam, I think. Hung, Huyen, and Nguyen. Is any one of you wants to say something from this title, Applying Machine Learning for Automatic Product Categorization? Do you think is it a classification or regression? Or someone wants to answer? Maybe Noradila?
Yeah, since it's a product categorization, then it's classification.
Yes, this is classification. So you can use, maybe you can make a new project for automatically categorizing your product using machine learning. Or you can also, this is the big data project. They use machine learning for analysis, or use machine learning for statistical matching. If you want to explore more about machine learning, I suggest you to visit this link. This is a cheat sheet created by sklearn. This is really useful because sometimes when you code something, you need a fast answer. Okay, I want to do linear regression. What is the code for that? What is the syntax for that? You can just go to this cheat sheet and then find, okay, for doing linear regression, I just can use from sklearn linear model, import linear regression, and then use this. And then I also suggest you to read this. This is also really useful. I learned a lot from this post from the data camp. And also, if you have time, you could also read a book. I suggest this book, Introduction to Machine Learning with Python. It's written by sklearn creator Andreas Muller. So it's really good book for you if you want to learn more and explore more about machine learning. And also the code that is used in this book is available here. Anyone familiar with GitHub here? Anyone have GitHub accounts maybe? Noradila, do you have GitHub?
No, I don't
No.
use GitHub. Yeah.
Okay. I think you should start using GitHub because it's really useful, especially if you have a project group and each of the person in the group has several has a different task and you want to merge your work together without destroying anything. It's really good to use GitHub.
Okay.
Yeah, and it's also good if you want to have a portfolio of the project that you have done. And GitHub also have so many examples, code examples. Sometimes when I need some inspiration about how to solve some problems, I just surveying inside the GitHub world and try to find a project that suits mine that I can use to finish my job. So this is the code that is used in the book Introduction to Machine Learning with Python. So let's say that you want to learn about the supervised learning. So you can use you can just start practicing in it and see if you got the correct answer or not. And that's it. That's my talk for today. I would welcome some questions from you. And if you want to connect with me, I have a GitHub account here, github.com/erikaris, or you can also reach me through the Twitter. Has anyone play with Twitter? Or not?
I do.
I do. Okay. Yeah, we already follow each other actually. So, yeah, so if anyone keen on using Twitter, you can also reach me through Twitter. So that's all my talk for today. Thank you very much for listening. Any questions? I will hand over to Mr. Sueka as our host.
Okay, thank you, Miss Erika, for very interesting presentation. Yeah, I think you successfully forced the participant to respond.
Yeah, even though it's only Noradila who answered. Yeah, sometimes there is another person too. But thank you very much for Noradila. You should get some souvenir from ASEAN Stat, I think, for being the most active participant.
I think Miss Farron has do it as well in the earlier part, right?
Yes.
Yeah, but she need to join via YouTube because there is something to do with the work, so she joined it via YouTube.
Yeah, totally understand.
I see.
Thank you very much.
Yeah, because we should very glad for active participant, especially from those in Malaysia. You can share your experience as well during the workshop, because I believe there is different implementation regarding the big data. Again, thank you again for the active participant. Before we continue, I will agree to take 10-minute breaks. How about Pari?
Yes, I think we can take 10 minutes break. The participant already doing very good, right? From 8 to 10:20.
Okay, agree. Give 10-minute time to participant to get relaxed. Okay, see you again in next 10 minutes.
Okay, see you. Thank you.
Thank you. Okay, 10 minutes is over. We can continue to the next presentation by Mr. Ari Wahyu. So, okay, Pak Ari, time is yours.
Okay, thank you, Pak Sueka. So, good morning, everyone. My name is Ari Wahyu Wijayanto. I'm from, actually, I'm a lecturer at Polytechnic Statistical ASEAN, which is part of the Statistic Indonesia, the BPS. So, let me share my screen. So, first of all, are all of the participants already here? Can you all hear me?
Yes.
Okay, thank you. All right. So, Miss Arika already explained a lot of things, right? So we already have learned many things from the supervised learning by using Python. And she also already explained a lot of things about the k nearest neighbor, about the decision tree, and she also mentioned that the decision tree has some limitation. So into this talk, I will give some brief introduction about the random forest, the methods that we usually use to handle the limitation of the decision tree. So let's take a look into it. If we revisit the decision tree, we know that the decision tree, we use it as a classifier. We use it to classify certain things into a different class. And we already know that it is a nonlinear classifier because we didn't use the linear model to classify the things into certain categories or certain groups. And Miss Erika already explained easily that it's easy to use. We can just use the scikit-learn. It's also easy to interpret because the interpretation is really easy, right? We only have a tree, whether such kind of thing should be categorized into one group or another, and so on. But the thing is, the decision tree is really susceptible to overfitting. Yeah. So, but it can be avoided because in decision tree, usually, if you already train it on the training data set, and then there is another new coming, the new records coming, and then you usually ask whether the new data will fit into our training data or not, right? So usually we have an accuracy is quite low with a decision tree. So this is susceptible to overfitting. So overfitting means your accuracy in the training data is higher, way higher than the accuracy in the testing data. So it means that it's only good to your training data. It's not good for your testing data. For any other incoming data, it may be not so good. Yeah, it's only good on the training data. So that means that the decision tree is only memorizing kind of things, right? It's only memorizing of things, and it produced the very simple things, right? So here it comes the random forest. In random forest, it can be avoided, this forfeiting. So what is the random forest? So let's take a look into the decision tree that already mentioned by Miss Erika, right? But in here, we have a tree in the decision tree, right? So for example, whether we should go for going to school or going to the office, whether it will be a good weather or not, right? So its note here is a test on one attribute. So for example, we would like to know whether the weather will be windy or not, whether the weather will be humid or not. How about the outlook? Is it sunny, or is it rainy, or and so on, right? And this one, each of them is the possible attribute values. Yeah. So the leaf is the decision. So for example, if you would like to go to the office and you would like to check, right? You would like to check whether the outlook will be sunny. If the outlook will be sunny, then we should check the humidity. If the humidity is high, then we should not go to the office, right? And if the humidity is normal, then we should go. So yes, we should go to the office. Otherwise, if the outlook is not sunny, right? If the outlook is overcast, then we should go to the office, right? How about if the outlook is not sunny and is not overcast, but it's rainy, then we should check another variables, right? The other variable is we should check whether it will be windy or not. If it's windy, yeah, so no, we should not go to the office. But it's not windy. If it's not windy, then yes, we can go to the school, to the office. Right? So this is the anatomy of the decision tree. So how we build this one, I will recap what Ms. Erika mentioned. How we build this one is based on the record, based on the data. So each data will have a participation on how we build this kind of things. Right? So let's say we have the sample size. Our data have a 500, for example, 500 records. If we have a 500 records, right, and we have a certain variables on that, whether the outlook, the humidity, and the windy. The first one, based on the outlook, only the outlook, and then we put it based on the result, based on the value of the variable. For example, this one is outlook. So we put it based on each value of the variables, right? All right. After that, we can have a certain things that have two different value. Yeah. For example, for all of the data that we have, if the outlook is overcast, fortunately, all of them mention that we should go to the school, to the office. So for the overcast, we have a right decision that we say that very confidently that we should go to the office. And so it's yes. But if it's sunny, right? From our previous experience, is we are not really sure. We are not really sure whether we should go to the office or not. Right? So sometimes we go to the office, sometimes not. So sunny itself is not enough, right? The sunny itself is not. So how we take a look on that? So we take a look on the second variables. If it's sunny, then we take a look on the humidity, right? And it's so on and so on. From here, we can see that from our sample size, from our previous experience, from the data, this 500 data, your data will get smaller to its branches, right? So here maybe 500 from 500 in the total samples, right? The one that having the sunny value, maybe only 300, right? And the one that having the rainy value, maybe only 100, and so on. So the data will get smaller and smaller, right? The leaf is the decision. Okay. As I mentioned earlier, that using the decision tree, it will be easily you can get the overfitting. So, for example, in our previous experience, we have this kind of decision tree based on our experience, based on our previous data, right? But the new data coming, today, we have an outlook sunny, and we also have the humidity normal. Based on this decision tree, we should go to the school, to the office. But it's not actually. But actually, it's raining, right? So it should not be go to the school. We are not supposed to go to the office. So it's violating the decision tree, right? So the accuracy will be decreasing. So this one means that it is overfitting, because in our testing data, the data is not suitable, or is not correct based on the decision tree. So this one is overfitting. It has zero bias, but it has high variance because the new data, we didn't know how the new data coming. So there are two approaches. The first one, we should stop growing the tree, but further, we have to split the data if it's not giving us the improvement. Or the second one, we grow the full tree and then we prune the tree. So it means that the second one, we prune the tree. If we have here the three branches, maybe we only focusing on the two branches, the sunny and the overcast, because the rainy ones, maybe there are no many data. There are not a lot of data here, only a few data here. So we just prune it. So this is the two approaches. Okay, there is one solution for this. The solution, we call it as the bagging and bagging. The bagging means the bootstrap aggregation. These techniques mean we reduce the variance of the estimated prediction function, right? For classification, some trees will give the food, right? So in bagging, instead of we create only one decision tree, we create a lot of decision tree, right? Usually we only have one decision tree, but in bagging, we create a lot of things, a lot of them. As Miss Erika mentioned that in decision tree, how you put the first variables here is by randomly or by selecting the first column or the first variable in the data, right? So how about if we have a lot of variables? Why we should put the outlook first? Why we didn't put the humidity first? Or why we didn't put the windy first, right? So in this bagging, sorry. So in this bagging, we can create a lot of different decision tree, right? Maybe the first one is something like this. The second one, we put the humidity first. Or in the third one, we put the windy first, something like that, right? So this is called as bagging. And at the end, we make a vote for each decision tree. So for example, if you have a data like a decision tree like this, and then you have a new incoming data, based on the new incoming data using this tree, the decision is something like this, maybe yes, in the end. But in the second decision tree, it has the no vote. In the third decision tree, we have a yes as well. So we have 2 yes and 1 no. So it means that we should go to the school. So this is the voting, right? But this bagging, how we can create the second decision tree, right? The second decision tree and the third decision tree, right? This is called as a bootstrap. Yeah. In the bootstrap, the basic idea is we create a random new data set. So we have one data set, and then we create the new data set from this one with replacement, with the same size as the original training data set, right? So let's say we have the training set, something like this, let's say 500 data sets, right? So we randomly select one by one from this training sample with replacement. It means that one record can be selected twice or 3 times or 4 times. There is no limitation on that. We can just put the selected randomly from that. And then we have one bootstrap samples here. The one bootstrap sample have the same size, it's 500. The second one, we also make the new one. We make the new one by randomly selected from the training sample, and so on, until we have something like 500 bootstrap sample. So now, how many data set that we have? How many data set that we have? Is there any of you that want to answer? We have 500 data set here, 500 records in one data set in the training samples, and then we make a randomly selected from that to create the new sample, the new samples. So how many that we have? So let's say we have this one. We do this 100 times. So how many data set that now we have? Is there any of you want to answer? Maybe Mr. Hung. I don't know. This one is Mr. Hung or Miss Hung from Vietnam. Do you want to answer? I think because you opened the mic.
Sorry, because you know the bootstrap is one difficult issue for me, so I'm just need to learn from you. I will ask the question later.
All right. No worries. We can learn together.
Yeah.
Okay.
The bootstrap
thank you,
is bootstrap is really difficult. Yeah, for me. Thank you.
Okay. No worries. I will show you the video after this. So this is just the theory. I will show you the video. I think the video will be really easy for us to understand, right? So
yeah,
first, we take a look in the theory. Maybe the theory is kind of like really hard, but after that, we will go to the code, and I will give some video of tutorials, so it's really easy. Okay, don't worry, Mr. Hung. Thank you.
Yeah, thank you.
Okay, we can continue, right? Going up again. So in the beginning, we have the samples, we have the training data, and then we create the bootstrap samples from the training data. It's the same size, right? It's the same size. And then we construct the decision tree from each of them, right? So instead of creating the only one decision tree from the training samples, now we have a lot of decision tree from each bootstrap, right? From each bootstrap samples, right? So it's easy. After that, we take the majority vote. In majority vote, you put the new the new data to each decision tree, and have what is the decision from each decision tree, and then we make the majority vote from that. So that's the final conclusion, right? So this one is called as bagging. In bagging, this one, instead of we have one method or one model, we have a lot of models. So that kind of mechanism, we call it as ensemble learning. In ensemble learning, we kind of doing it in many models, right? So sometimes one model is not quite good. The other model is good for something like some issues, but have another limitation. So why don't we come up with a lot of models at once? It's parallel. So this is the idea of the bagging. In the bagging, we have an ensemble. We have a lot of models at once, right? In mathematically, in bagging, we have a summation. We have a summation of the prediction, right? So the prediction of each model, we make an average of that. So I already mentioned this is the majority vote, right? So the simulated example. So for example, we have a data set that have the sample size equal to 30 with two classes, right? And the variables or the columns, we have 5. And let's say we have each column have the normal distribution. Normal distribution or Gaussian distribution. This is the normal distribution. And the pairwise correlation is 0.95, right? And then we know that for the first class, right, first category, we all of them has a 20%. So all of the data belong to the first group with 20%. And the 80%, the remaining 80% belong to the second group, right? So this is the begging example, from our previous one, in the begging one, now we have different three, right? From the original one. We have 1, 2, 3, 4, 5, and 6. So we have a different tree, right? We have a different tree. The complete tree, the full one. If we take a look into the distribution of that, we can see that sometimes from its decision tree, the new incoming data or the testing data have the different accuracy for each of these, right? Miss Erika already mentioned what is the meaning of the accuracy. So the first accuracy, let's say 80%, the second accuracy is 70%, 60%, and so on, right? If we take a look on the error, it means that the 100 subtracted by the accuracy, this one is the error, and we compare the number of bootstrap samples, we can see that the test error of the original tree and the back tree is a function of the number of bootstrap samples, right? So we can see here that the orange point, this one is correspond to the consensus vote, yeah, while the green point represent the average probabilities. Yeah, sometimes the consensus or the majority vote from the all of the decision tree is not the same as the average of the probabilities, right? But the larger of the bootstrap sample, right, the better. It means that the consensus will be similar to the average of probability. So here we can answer that how many samples that we should create, how many bootstrap that we should create. The larger, the better, right? The more, the better, right? So this one. So in this one, we see that with begging, yeah, with the begging that I mentioned before, we have an ensemble of structurally similar trees. But this causes the highly correlated trees because one tree and another tree highly correlated. How is the solution? The solution is we create the tree that have no correlation or the weak correlation. Yeah. This one is called as random forest. Yeah, as random forest. Random forest is an extension to the baking that I already mentioned before, but we only use the decorrelated trees. So it's simplified. Yeah. The first one, we have the training data, something like this, and then we create the bootstrap samples from the training data. And then from its training data, instead of using the full decision tree, we use the simplified decision tree. So for example, if we have 5 variables, we didn't use all of the 5 variables, but we only use randomly 2 variables or randomly 2 columns, right? And then we split the feature, right? And then we create the decision tree from each bootstrap sample, similar to the bagging, but in here, the decision tree is much more smaller. It's much more smaller.
Sorry
right?
to
And then we
interrupt,
take the
Mr.
majority
Ari.
vote. Yeah,
I have a question.
please go ahead. Yes, please go ahead.
Okay. For the sample, we use the training sample from the orange
Exactly.
box, right? So
Right.
will the sample replicative for each of the green box, or it will only appear once?
Good question. Okay, good question. Okay, the answer is really easy. Let's say here we have the samples, like the samples is A, B, C, D, and E. Okay, we have five samples, A, B, C, D, and E. For the first bootstrap, we randomly selected 5, right? The randomly selected. So it can be A and then B and then A again and then C and then E. A, B, A, C, and E.
Okay, okay. So it will
And
be
the second,
replicated.
yeah, it can be replicated. In the third one, maybe A and then A and then A again and then B and then C. It's randomly. Yeah, so it's randomly. Did I answer your question?
Yes, yes. Thank you.
Okay, yeah, thank you. Okay, so it's really easy. This one is the bootstrap sample, right? So in here, how many splitting variables that we should use? Yeah. In here, there is an experiment conducted by the previous researcher that the number of randomly selected splitting variables, the more is the better. The more is the better. But the correlation should not be the running time. I mean, the running time will be increasing, right? So the simpler the decision tree, the better. Okay, so let me give you the summary of the random forest algorithm. The first one, we take a random sample of size n with replacement from the data, right? And then we take the random sample without replacement of the predictors, right? And then we construct the first decision tree from the data. And then we repeat that for its split. And then we repeat to steps 1 until the step 4 a large number of times. It's really confusing. Okay, don't worry. I will show you the real example, right? I will show you the video. How to create the bootstrap dataset, right? This video has sound, so if you can hear the sounds, let me know, or if you have any issue on hearing any sounds, let me know.
Step 1, create a bootstrap data.
Can you hear the sounds?
Yes, very clear.
Okay, thank you. Okay, let's continue, right?
Imagine that these 4 samples are the entire data set that we are going to build a tree from. I know it's crazy small, but just pretend for now. To create a bootstrap dataset that is the same size as the original, we just randomly select samples from the original dataset. The important detail is that we're allowed to pick the same sample more than once. This is the first sample that we randomly select. So it's the first sample in our bootstrapped dataset. This is the second randomly selected sample from the original dataset. So it's the second sample in our bootstrapped dataset. Here's the third randomly selected sample. So here it is in the bootstrapped dataset. Lastly, here's the fourth randomly selected sample. Note, it's the same as the third. And here it is. Bam! We've created a bootstrap dataset. Step 2 for creating a random forest is to create a decision tree using the bootstrap dataset, but only use a random subset of variables or columns at each step. In this example, we will only consider 2 variables or columns at each step. Note, we'll talk more about how to determine the optimal number of variables to consider later. Thus, instead of considering all 4 variables to figure out how to split the root node, we randomly select 2. In this case, we randomly selected good blood circulation and blocked arteries as candidates for the root node. Just for the sake of the example, assume that good blood circulation did the best job separating the samples. Since we used good blood circulation, I'm going to gray it out so that we focus on the remaining variables. Now we need to figure out how to split samples at this node. Just like for the root, we randomly select 2 variables as candidates instead of all 3 remaining columns. And we just build the tree as usual, but only considering a random subset of variables at each step. Double bam! We built a tree, 1, using a bootstrap dataset, and 2, only considering a random subset of variables at each step. Here's the tree we just made. Now, Go back to step 1 and repeat. Make a new bootstrap dataset and build a tree considering a subset of variables at each step. Ideally, you do this hundreds of times, but we only have space to show 6. But you get the idea. Using a bootstrap sample and considering only a subset of variables at each step results in a wide variety of trees. The variety is what makes random forests more effective than individual decision trees. Sweet! Now that we've created a random forest, how do we use it? Well, first we get a new patient. We've got all the measurements, and now we want to know if they have heart disease or not. So we take the data and run it down the first tree that we made. Boop-a-doop-a-doop-a-doop-a-doop-a-doop-a-doop. The first tree says yes, the patient has heart disease. And we keep track of that here. Now we run the data down the second tree that we made. The second tree also says yes, and we keep track of that here. And then we repeat for all the trees we made. After running the data down all of the trees in the random forest, we see which option received more votes. In this case, yes received the most votes, so we will conclude that this patient has heart disease. Bam! Oh no, terminology alert! Bootstrapping the data, plus using the aggregate to make a decision, is called bagging. Okay, now we've seen how to create and use a random forest. How do we know if it's any good? Remember when we created the bootstrapped dataset? We allowed duplicate entries in the bootstrapped dataset. As a result, this entry was not included in the bootstrapped dataset. Typically, about 1/3 of the original data does not end up in the bootstrapped dataset. Here's the entry that didn't end up in the bootstrapped dataset. Psst. If the original dataset were larger, we'd have more than just one entry over here. This is called the out-of-bag dataset. If it were up to me, I would have named it the out-of-boot dataset, since it's the entries that didn't make it into the bootstrap dataset. Unfortunately, it's not up to me. Since the out-of-bag data was not used to create this tree, we can run it through and see if it correctly classifies the sample as no heart disease. In this case, the tree correctly labels the out-of-bag sample no. Then we run this out-of-bag sample through all of the other trees that were built without it. This tree incorrectly labeled the out-of-bag sample yes. These trees correctly labeled the out-of-bag sample no. Since the label with the most votes wins, it is the label that we assign this out-of-bag sample. In this case, the out-of-bag sample is correctly labeled by the random forest. We then do the same thing for all the other out-of-bag samples for all of the trees. This out-of-bag sample was also correctly labeled. This out-of-bag sample was incorrectly labeled, etc., etc., etc. Ultimately, we can measure how accurate our random forest is by the proportion of out-of-bag samples that were correctly classified by the random forest. The proportion of out-of-bag samples that were incorrectly classified is the out-of-bag error. Okay, we now know how to 1. Build a random forest, 2. Use a random forest, and 3. Estimate the accuracy of a random forest. However, now that we know how to do this, we can talk a little more about how to do this. Remember when we built our first tree and we only used 2 variables, columns of data, to make a decision at each step? Now we can compare the out-of-bag error for a random forest built using only 2 variables per step to a random forest built using 3 variables per step. and we test a bunch of different settings and choose the most accurate random forest. In other words, 1, we build a random forest, and then 2, we estimate the accuracy of a random forest. We change the number of variables used per step. And we do this a bunch of times and then choose the one that is the most accurate. Typically, we start by using the square of the number of variables and then try a few settings above and below that value. Triple bam!
Okay, I hope it's really clear right now, and we now can come to the hands-on. But before the hands-on, is there any question about the random forest? If you have any question about how we can perform the random forest, you can raise your hand. But so this is still really simple, right? The random forest is still really simple. So actually the supervised learning contains a lot of things, a lot of models, not only the random forest. We have a lot of more sophisticated models that we can try, but right now we can just focus on the random forest. Now I will share the hands-on. Okay, can you see my screen? By the way, if you already have, okay, thank you. Yeah, so if you already have an access to the Google Drive, I already upload my code here, and you can try to use that one on the Google Colab. And if you already downloaded before this session, I put some additional description. So maybe you can just update your file using the newest one, because this one I already updated with some description. So it's really easy. In this example, we would like to predict, the real case. This is the real case of, can we predict the maximum temperature of tomorrow temperature in one of the cities? When I check the data, in this case, we use the data in NOAA, the National Oceanic Atmospheric Administration, for the city in Seattle in Washington. So the first one, what we have to do is we download the data, right? So the first one, we should go for the data acquisition. And then after that, we should identify the anomalies. As Miss Erika mentioned in the previous section, and I think Pak Satya already mentioned yesterday, that we should do the data cleaning, right? So we should do the data cleaning by identifying the anomalies. After that, we can use the data preparation, and after the data preparation, we can make the training set and the testing sets, and then do the training, train the model, and then make prediction on the test data, and then improve the model. Okay, let's do it one by one. In the data acquisition, first of all, you should mount your drive here. Okay. In this one, if you haven't done this one previously, the Google Colab should ask you to sign in into your Google account. So for example, let's say I will run it all. Oh, I already have signed in on this one, but you can try. Is there any of you want to volunteer? If you have any problem on this one, you should have problem in this one, because Google Colab will always ask you to sign in. Is there any of you want to try? Okay, I think I should ask for one participant, maybe random roulette, random roulettes. Mr. Rachel from Philippines, do you want to volunteer? Or Miss Farron? No? Okay. So let's assume that all of you guys have no issues here, because what you have to do is just sign in to your Google account, and then after you mount the drive, and then you just import the pandas, and then you have to go to the CSV file. The CSV file here, I put it in our Google Drive in the part 3 and the day 2 and the data. The file is the temperatures, the CSV. We have a lot of variables here: the year, the month, the day, week, the temperature in the 2 days before, the temperature 1 day before, the average one, the actual one, the forecast by NOAA, right, and the forecast, the accuracy, and then yeah, I put the description here. So if all of you already downloaded before this section, I already put the new description here. So the average is the historical average maximum temperature, and then the actual is the actual one, the correct one, the maximum temperature measurement. And this is the funny one, right? The friend variables. The friend variable is your friend's prediction. Yeah, friend prediction. How we put this one actually? This is just for fun. It's a random number between 20 below the average and 20 above the average. So this is the random one, right? And then we identify the anomalies. Yeah. So the first one, we take a look into the shape of our data. In this one, the shape of our data consists of 348 records or rows and 12 variables or 12 columns. And then we provide the descriptive statistics. We take a look into the count, the mean, the standard deviation, and the minimum one, the first quartile, and so on, right? And then we use the date time for dealing with the dates. Yeah, because in here, the date, the day, and the months and year is not in the date time version. So it can be easily done by using the each years, months, and days into the features, and then list and convert them into date time object. Yeah, and date time object. In here, we can use the matplotlib libraries. It's really easy. The matplotlib libraries is really easy. We can use it for plotting our visualization using, yeah, this is the magic comments that you can use in Jupyter Notebooks as well as in the Google Collaboratory, right? And then we set up the plotting layout. For this one, you can use this kind of code, or if you want to explore more about the matplotlib, you can go to the matplotlib website and then check how to create the subplots, right? The subplots here. And we use the actual maximum temperature measurement as a labels, and then the temperature from 1 day before, and then the 2 days before, and then the friend estimate. Yeah, and then we have this kind of visualization. Yeah, from this one we can see the anomalies, right? And here in the 2 days prior the maximum temperature, there is an anomaly, right? As well as here, the previous maximum temperature is, we have an anomaly here, right? So we have an anomaly here, and then we should do the data preparation. Yeah, in data preparation, Because most of the models or in random forest provided by scikit-learn, it's only use the numeric variables. So we should convert the categorical data into the numeric data, something like this. For example, the week here is Monday, Tuesday, Wednesday, Thursday, and Friday. We should convert it into the number, right? How we can convert it? The first one, maybe we can convert the Monday into 1, Tuesday 2, Wednesday 3, Thursday 4, Friday 5, and so on. But it should be wrong, right? It should be wrong. Why? Because in that case, the Tuesday will be twice as much Monday, and Wednesday will be 3 times of Monday, which is not correct, right? So instead of directly converting this categorical data into numerical data, we keep the categorical data as categorical data, but save or store as a numeric. So this one is called one-hot encoding. So here we create 5 columns, 5 additional columns, Monday, Tuesday, Wednesday, Thursday, and Friday, and put each of the day in each corresponding column, and so on, right? After that, we have the new data here, right? We have the new data where we already convert the week. Yeah, we already convert the week. See, here we already converted the week Friday, week Monday, week Saturday, Sunday, and so on, because this one is sorted alphabetically. So we already have another variables. We can call it dummy variable. In statistics, we can call it dummy variables. Yeah, or in machine learning, we can call it one-hot encoding. Yeah, and then we convert the feature and labels and convert the data into arrays. Yeah, where we can use the NumPy. Yeah, Miss Erica already mentioned about this as well, to convert the arrays. This is very useful libraries that we can use for mathematical operation, as well as converting from one data to another type of data. Yeah, and the value that we want to predict, we make it as a label. Right. Miss Erica already mentioned about the supervised learning consists of several class or labels. So the feature or the variables of actual will be set as labels or class here, right? And after that, we remove the labels from the features. Yeah, we remove the label from the feature because we don't want the actual variables, the actual column, will be the data that will be processing later. So we remove that, right? And then we convert all of this data into NumPy features, yeah, and then we can process it. And in here, we can use the scikit-learn as well, yeah, to split the data. Yeah, we can split the data into the testing data and the training data. Yeah, training set and the testing set. Then we can split it. Then we can print. Yeah. So in here, we use the split data. Yeah, the test size. The test size is 25%. So we split the data 75% as a training set and 25% as a testing set. So finally, we can have 261 data as a training, and then we use 87 data as a testing, right? After that, we can create the baseline. Yeah, what is the baseline? The baseline is just for our comparison. Yeah, for our comparison, because we want to create the random forest, and then we make the new baseline to check whether our random forest is already quite good or not, right? It's really easy. Yeah. Okay, and then we train the model. Yeah, in the train the model. Same as before, we use the scikit-learn. It's really convenient for us to remember to use the library scikit-learn ensemble and then import the random forest regressor. Yeah, if some of you already familiar with some other classifier, KNN classifier, decision tree classifier, here we use the random forest regressor. And then we use how many trees that we should create. Yeah, this is the good example, right? The good question from the previous explanation, right? How many trees that we should create, right? The larger, the better, right? So here we use 1,000. Yeah, we use 1,000. And then we feed the training data into our random forest model. Yeah, and after that, we can just make a prediction. Yeah, after we train our random forest using the training set, later on we make a prediction based on the testing data. Yeah, it's really easy. We can use the rf.predict and then use the test features. Yeah, test feature, and then we can calculate the absolute errors by make the absolutes from the prediction subtracted by the test labels, whether our prediction is correct or not based on the test level, because we already have the labels for all of them, right? And now we can create the mean absolute error, or MAE. Yeah. In this case, we have 3.87 degrees. This is the mean absolute error, right? But how about the accuracy? We only care about the accuracy, whether our prediction using random forest is accurate or not, right? Yeah. So it's really easy. The first one, we can just create the mean absolute percentage error. Yeah, as we already learned a lot in statistical field, right? Which is the 100 times the number of errors divided by the test levels, how many test levels that we have. And then we calculate the accuracy. The accuracy is just 100 minus the mean absolute percentage error, yeah, the average of that. So the accuracy here, we have a 93%, 93.93%, which is, yeah, but quite good, yeah, not so bad, yeah. So in here, we already have the prediction model to predict the weather, tomorrow weather, the temperature in the Seattle city in Washington. So we can also improve if necessary. Yeah. How we can improve? The first one, if we create a different hyperparameter. Yeah. So for example, we have the number of estimator, and then we have the maximum depth, and then we have the number of minimum sample split, and then how many samples live are there, and so on and so on. Don't worry, you can just try different parameters here, and then you can have another different model, a random forest model, and then you can compare it with the current accuracy that we have at first, right? In the first. Until now, I think it's really easy for you. And if you have any question, you can raise your hand. If not, I will just continue. The first, how we can visualizing. Yeah, this is just not only the result, but we have a visualization for that. In here, I use the graphics. Yeah, graphics for visualization. Yeah, so here we can just have the visualization. The visualization here is quite small, but you can download it in here. Yeah, this is the working directory that you can just download by using this code. The tree.png, you can just download it, and then you can see it in the larger resolution. Yeah. And after that, we can just make the smaller tree visualization as well. If this kind of tree is too small for you, you can just focus on the smaller branch which brand that you want to focus, we can create a smaller tree for visualization. Yeah, in the smaller tree for visualization, basically we just limit the depth. Yeah, the depth of the tree. Yeah, if this kind of tree is really big because it's really deep. Yeah, it's really deep. So we can just limit the depth of the tree. Yeah, the depth of the tree, for example, only in 2 levels. So it's really easy. Yeah. So we can have the small tree here. Okay, the small tree is here. We can see. Okay. Can you still see the small tree? I think I should reshare again. Voila, we have the small tree, right? And here we just focus on one of the branch. Yeah. So we have the smaller tree, and so it's pretty easy to check which brand that we should focus on. Okay, let's go back to the Google Colab. If you have any question, please ask me any question and raise your hand. I will be happy to answer your question. Yeah. And next, we can just improve our random forest by checking the variable importance. So actually, which variables really contribute to our predictions. So this one, I put the variable importance checking here. You can check it by yourself. So in here, we can see that the variables of maximum temperatures 1 day before has higher importance than the other variables. So it's really easy to check. The second one is the average temperature, right? And the forecast and so on. But the week has no importance. We can see here. There is no importance of having the data of week or year here. Yeah, right? Well, it can be different for any type of data, any other data, it can be different. So, but we can check how much is the importance of each variables to our prediction. Yeah. And after that, we can have a new model. We can have a new model. Instead of using all of the feature, all of the variables, yeah, we can only focus on 2 most important variables or 2 most important features. Yeah, so it's really easy. So here we will be focusing on the temperature one, which is maximum temperature 1 day before, and the average temperature. Yeah, in here we create the new random forest. Yeah, new random forest with the feature only temperature 1 and the average. Yeah, and then we can train and test as well. Fit, training, and then make prediction, and then test. Right, and then we have the accuracy. Oh, the accuracy is increasing. Yeah, yeah, right. Yeah. So the I'm sorry, it's not increasing. Sorry. Previously we have 93.93. Yeah. In this one we have the accuracy decreasing. Not that big. Yeah, not that big. We have a 93.76%. It's decreasing the accuracy, but keep in mind we only use 2 variables. 2 variables instead of a lot of variables to get 93.93%. With only 2 variables, we can use 93.76%. It's a lot of time that can be saved if you running the huge data sets. So don't use all of the variables. You can just focus on the most important variables in the model. Yeah. And then we make a visualization, for example, and so on. Yeah. So in here, this is the variable importance. Yeah, we can see that the first temperature 1 day before and the average temperature is really important, and then make the prediction and so on. And in here, we can check, we can plot the actual and the prediction. The actual and the prediction. Yeah. I think it's already finished. I already covered all of the materials. If you have any question, please raise your hand. I will be happy to answer it.
Yes, I have a question, Mr. Ari.
Yeah, please.
You shown the accuracy just now. My question is, how does the accuracy being calculated? Is it based on confusion matrix?
Exactly. Based on confusion matrix. So it's really easy, right?
Okay, thanks.
Yeah. Because in the original data, we actually have the correct labels for all of the data, right? So we can just check whether our prediction is correct or not. Yeah, you can use the confusion matrix. And don't worry, we don't have to calculate manually using the confusion matrix. The scikit-learn already doing it, all of them for us. So it's really easy.
Yeah, thank you. Got it.
Okay. Is there any other question? If we have no question to conclude this workshop today, please keep in mind, all of the participants, that what we have learned today is kind of very basic. You can learn a lot if you want to into deeper model. For example, the more sophisticated model, let's say the support vector machine, or the neural network, or deep learning, and so on. But the basic one that we already covered today will give you the foundation how you can learn other sophisticated model as well. And I think that's all from my side. I hope you guys will try the code, and I think I will also upload the video to the Google Drive. And if you have any question, please, you can contact me, or after this workshop you can also contact me by my email as well. I will put it in the chat box. Okay, and I think we already covered all of the material, and the time now for Pak Sueka. Okay, thank you, Pak Sueka.
Okay, thank you very much, Pak Ari, for the presentation. Before we conclude, may I give one question?
Sure.
Okay. Our topic is supervised machine learning. So can you give me insight at which part from your presentation that highlight the supervised compared to unsupervised? Just quick brief.
Okay, good question. Thank you. So in our presentation today, especially in my side, we predict the temperature, right? We predict temperature. In the prediction, the temperature, basically there is a correct answer. It is a correct answer, right? But sometimes the correct answer is not known right now, but maybe tomorrow. But there is a correct answer, right? That is the supervised version. Yeah, supervised version always have the correct answer, but unsupervised, we don't have the correct answer, because we just want to learn about the natural groupings or the natural phenomena. So for example, in unsupervised, we have a clustering. In clustering, there is no correct answer. We just want to have the natural groupings of the data. So for example, we want to cluster the temperature. the temperature can group into a certain cluster, but there is no correct one. We just want to know how they group to each other. So that's the thing. So the main difference is whether we know the correct answer or not. Yeah.
Okay. Okay. Thank you. I think I cannot catch all the explanation, but because but it is very interesting to compare to tomorrow topics. I hope I can get the big picture for the machine learning. Thank you. Okay. Please give applause to our trainers today, to Miss Erica and Pari.
Thank you.
Thank you. And I think we have a lot of good discussion today. The chat box is really full of fruitful discussion. Yeah. So
Yeah.
if you will have any further discussion, just reach us at comments or reach us at emails. Yeah. I'm actually a lecturer, so I'm really happy to answer any other question. Any question.
I particularly will thank Noradila and Ms. Peron for being such an active participant and make this discussion really lively. So thank you very much, and also for other participants.
Yes. Okay. As highlighted that if you have any question or want to know about our presentation today, please feel free to drop your email to ASEAN Secretariat or based on the email shared by Pak Ari. Thank you again for your participation. We meet again tomorrow. Tomorrow is the last day of this week part. That means also the last workshop in our series of the last session of our series of workshop. So tomorrow we will have for data scientists we will have topic about unsupervised. So I mean supervised. And closing session. And also photo session. So don't miss it to join tomorrow. There will be some remark from representative from the Asian Stat, BPS, and also the DOSM. Thank you.
Mr. Sueka, is it possible for us to have a group photo before ending the session today?
Oh, for today?
Just for a word report, something like that. For
okay.
True.
May I ask all participants to turn on your camera? All
no one turn
participants.
on the camera. Okay, I see Mr. Hu from Vietnam, and also Miss Peron. Okay, I see Naradila.
เปิดกล้องเนี่ยเปิดกล้องก่อน
Okay. Let me check other participant.
Good. We can have a photo session.
Okay. Okay, another one is join. Yes, I got the picture from each participant.
Thank you very much, everyone.
Thank you.
everyone.
Thank you.
See you tomorrow.
Thank you.
You're
Thank
welcome.
you. Bye.